A dramatic shot of interstellar object 32 Atlas sweeping past Mars in early October 2025. Two European spacecraft, the ExoMars Trace Gas Orbiter and Mars Express, are positioned 30 million kilometers from the object. Close-up of the ExoMars Trace Gas Orbiter and Mars Express spacecraft as they attempt to capture images of the faint, distant, and moving interstellar object. The Color and Stereo Surface Imaging System, CASIS, aboard the ExoMars Trace Gas Orbiter begins taking exposures of 32 Atlas. A remarkable image appears on the screen, a faint, fuzzy white dot drifting slowly downward. This dot represents 32 Atlas. Animation illustrating the coma of the comet, a hazy halo of gas and dust surrounding the nucleus as it warms up near the sunday. Visualization of the comet's nucleus, estimated to be a few kilometers wide, as it is too small to resolve directly. The coma, spanning several thousand kilometers, glows softly against the background of space, a testament to the sun's heat. Frozen gases vaporize, dragging clouds of dust outward, forming a luminous envelope around the comet. The brightness of the coma drops quickly with distance from the core, fading into the background noise of the image. A shot of a comet with a long tail stretching millions of kilometers, contrasting with 32 Atlas, which has no visible tail yet. The CASIS data suggests that 32 Atlas's tail is still too faint, just beginning to form as the comet accelerates toward perihelion. Nick Thomas, the principal investigator of the CASIS camera, explains that the comet is 10,000 to 100,000 times fainter than usual Martian targets. Over on Mars Express, its onboard cameras take shorter exposures, only half a second each, compared to the ExoMars orbiter's 5-second limit. Scientists combine multiple images from Mars Express to boost the signal, hoping the faint interstellar glow will reveal itself once the data are stacked. Both orbiters attempt to measure the spectrum of light from the comet, though it is unclear if the object is bright enough. Scientists reprocess and stack the data, searching for clues about 32 Atlas's composition and behavior under the sun's radiation. On October 4, 2025, one of Perseverance's navigation cameras quietly catches a thin, glowing streak cutting through the Martian sky. Close-up of the Perseverance rover's navigation camera, not meant for astronomy, but still capturing the interstellar comet. The navigation camera scans the Martian sky above Jezero crater, picking up the unmistakable trace of the interstellar comet. The image appears on NASA's website as Image of the Week, showing a long and symmetrical streak. Animation illustrating how each pixel covers a huge chunk of space when the rover looks at something far away, like 32 Atlas. The bright stripe looks about 4 times longer than it is wide, seemingly making it almost 50,000 kilometers long. Earlier measurements by the Sphere-X mission placed an upper limit on the object's true size at just 46 kilometers. The NavCam stripe is about 1,000 times longer than the real object could possibly be. Hubble Space Telescope images from July 2025 show a tiny, unresolved point of light, confirming that the stripe is not a physical structure. The best explanation: motion blur. The imaging team stacked hundreds of short exposures over several minutes to catch something so faint. During that time, 32 Atlas moved noticeably against the background stars, creating a blurred streak in the image. The best photo of 32 Atlas from the Perseverance Mastcam is processed by a Twitter account, link in description. Several orbiters circling Mars, including the Mars Reconnaissance Orbiter, were pointed toward the same patch of sky that night. For a brief window, 32 Atlas became one of the most closely watched interstellar visitors ever, captured simultaneously from orbit and the surface of another planet. The image that may settle the size debate will come from the HiRISE camera aboard the Mars Reconnaissance Orbiter. HiRISE achieved a resolution of about 30 kilometers per pixel during its October 3rd observation, 400 times finer than NavCam. NASA websites and feeds go silent, affected by a government shutdown at precisely the moment real-time updates are needed. Researchers around the world eagerly press to follow what might be the most unusual object ever seen in our solar system. Speculation arises. Is it a highly active comet, a probe from beyond the stars, a piece of technology, or an alien craft? On October 2nd, the Perseverance rover imaged a streak across a multi-minute exposure sequence. That streak does not match the normal motion of Mars's sky background. It's slanted and consistent across images, moving fast. Drew's post on Twitter spurred further review of the streak captured by Perseverance. Lower limit proposals cluster around 5 kilometers wide for the object's size, possibly more. It lacks the huge, classic dust tail of a comet. Instead, it seems to be cloaked by a vast, diffused coma of ionized gas and dust. The object's speed is extraordinary, roughly 60 kilometers per second, accelerating toward a peak near 68 kilometers per second as it nears perihelion. Around September 25th, a coronal mass ejection struck 3-2 Atlas, potentially ionizing or energizing its surroundings. Follow-up images taken on September 27th and October 2nd show no cataclysmic restructuring, only hints of gradual expansion in its envelope. The upcoming JUICE mission will intercept the object as it continues toward perihelion, although data delivery will be delayed. These assets could stitch together a better portrait of 3-2 Atlas. The mystery of the stripe has nothing to do with alien engineering, and it's nowhere near as massive as some are claiming. Figuring out how big a comet really is can be difficult, as it's hard to tell the nucleus apart from the hazy coma around it. As a comet draws closer to the sun, its frozen ices turn directly into gas, dragging streams of dust out into space, forming a coma. A team from Harvard led by Richard Kluge, Avi Loeb, and Peter Vez analyzed observations of 3-2 Atlas. The team compared the actual trajectory to the path we'd expect if only gravity acted, finding a tiny but noticeable push. Comets with active outgassing usually get a slight push from the jets of escaping gas. In 3-2 Atlas's case, the measured non-gravitational acceleration is surprisingly low relative to the observed outgassing. Researchers estimate the comet's core weighs over 33 billion tons, with a diameter of roughly 5 kilometers, not counting the surrounding coma. 3-2 Atlas appears to be about 3 to 5 orders of magnitude more massive than earlier interstellar visitors. Loeb has argued that we should have seen far more interstellar objects of more modest sizes before stumbling into one so massive. Loeb even entertains a speculative alternative that the object could be of technological origin. NASA scientists urge caution, with the prevailing view remaining that it is most likely a natural object. Images show that the object is active, with a coma around the nucleus, indicating that it is, in fact, a comet. Some scientists aren't asking what 3-2 Atlas is, but what its purpose might be. Astrophysicist Suzanne Ferner's idea: 3-2 Atlas may be a planet-making seed. We enter a young solar system, where a new star sits at the center of a great dusty ring. Tiny grains of rock swirl like smoke, clumping together into pebbles. With time, they snowball into boulders and then into planetesimals, the raw ingredients of planets. These planetesimals grow massive enough to gather even more material. Disks only last a few million years before the gas is blown away, a window that seems too short for massive planets to form. An interstellar object falls into this disk, a body already big enough to serve as a ready-made core. Instead of starting from dust grains, the disk suddenly has a solid seed that can immediately start pulling in surrounding gas and material. An alien traveler could speed up the birth of a new planet. FNR's simulations support this idea, showing that massive stars are better at capturing interstellar objects than smaller ones. Gas giants are more common around bigger stars. Interstellar objects like Oumuamua, Borisov, and 3-2 Atlas aren't just drifters. They may be the sparks that ignite planetary systems. Some might have seeded gas giants in faraway systems. Others may have played a role in our own solar system's early history. Interstellar objects are notoriously difficult to study. They appear suddenly, move quickly, and vanish into the dark. But this time, we're ahead of the curve, as we have detected it well in advance. Our technology may finally let us uncover its true nature, rather than just guessing after it's gone. A view of the vastness of space with distant stars and galaxies, a simulation of interstellar objects traveling through space at incredible speeds. Visualization of scientific data and models used to analyze 3-2 Atlas. Illustration of different theories and hypotheses about the object's origin and purpose. Scientists working in a control room, monitoring data, and communicating with each other. A close-up view of a computer screen displaying complex scientific data related to 3-2 Atlas. A visualization of the interior structure of 3-2 Atlas based on available data and scientific models. A simulation of the impact of 3-2 Atlas on a young planetary system. A comparison of 3-2 Atlas with other known interstellar objects. A view of the Earth from space, emphasizing the interconnectedness of our planet with the cosmos. A call to action for viewers to learn more about space exploration and scientific discovery. A montage of images and animations highlighting the beauty and mystery of the universe. The title card for the VO video, featuring the name of the video and the date. A scene depicting the different scientific instruments used to study 3-2 Atlas. A depiction of various alien life forms and technologies, representing the range of possibilities. An animation illustrating the concept of interstellar travel and communication. A simulation of the formation of new planets and solar systems. A visual representation of the scientific process, including observation, experimentation, and analysis. A depiction of the human quest for knowledge and understanding of the universe. A reminder to the viewer to stay curious and never stop asking questions. A scene depicting the collaboration and teamwork required for scientific exploration. A celebration of the achievements and discoveries of the scientific community. A shot of the Earth from space, emphasizing the importance of protecting our planet and its resources. The credits for the VEO video, listing the individuals and organizations involved in its creation. A final message of hope and inspiration, emphasizing the potential for future scientific discoveries. Visual of a graph comparing the sizes of known interstellar objects to 3-2 Atlas, highlighting its outlier status. Animation illustrating the gravitational interactions between 3-2 Atlas and other celestial bodies. Split screen showing images from different observatories around the world contributing to the study of 3-2 Atlas. A timeline showing the key events and discoveries related to 3-2 Atlas's passage through our solar system. Visualization of the potential future trajectory of 3-2 Atlas as it continues its journey through space. Animated infographic explaining the different components of a comet, including the nucleus, coma, and tail. Simulated view from the JUICE mission as it approaches 3-2 Atlas. Map of the solar system showing the locations of the various spacecraft observing 3-2 Atlas. Diagram illustrating the different types of radiation and particles emitted by 3-2 Atlas. Animation showing the formation of the solar system and the role of interstellar objects in this process. Visual representation of the scientific models used to predict the behavior of 3-2 Atlas. A series of still images showing the evolution of our understanding of 3-2 Atlas over time. A depiction of the potential impact of future interstellar objects on our solar system. End screen with links to relevant websites, articles, and videos for further learning.